Well, I hope you guys enjoyed that first episode. We got a little bit of work done, and this episode we're going to start to understand the mechanics of the machine a little bit better, figure out some weight and balance stuff, and keep this project moving forward. Welcome back, everybody. Round two here of what goes through Mark's brain when trying to design a simple tattoo machine. So let's get back to where we were. I think we were on overhead 3 is where we left off. So what were we? All right, we got the basic rear housing completed. We've got the RCA jack extension on there, and the motor looks like it's pretty well seated, and there we go. So, all right, so at this point, I'm not going to concern myself with how I'm going to attach the front cover to the rear housing. There is a multitude of ways to do that. And whatever I do will most likely double as the seating process, or apply some pressure to the outer perimeter of this motor to hold it in place without including additional fasteners and things like that. I don't love doing that. Having too many parts, I don't like it. It's just me. Nothing wrong with it. It's just more parts to buy, more parts to inventory, more parts to install, more things to loosen or come out or create problems down the road. I want to minimize virtually everything when no matter what I'm designing. So, all right, let's turn off some of this stuff. Let's turn the origin off, the analysis off. I think that's a motor sketch we have on in there. Okay, let's do this. I remember we rushed through it and I did not follow my normal procedures of naming things. So what is this sketch? Okay, that is where is that one located? Why are you not allowing me to select that? All right, let's get in the motor. Okay, no, that's what I created when I created the motor. That's my center point for the face of the motor here. Okay, this one is, let's see, call that center face, and this one here's rear pattern. You know, these do not need to make sense to anybody else. Just my own well-being here. And the motor housing. What did we do here? What is this sketch? Let's turn off the bodies. Let's turn off the sketches on the motor. And turn off sketches in there. So this is, let's turn off the motor itself. Okay. So that is our rear face. All right, we'll call that our rear face. And what is this one? Okay, we'll call that our CA face, sure. And just turn that off. What's this one? that one was to clear out the RCA, so we'll call it RCA clearance tube because we hollowed it out. And then this one here, I believe, is going to be the motor face tube. Yep, that we hollowed out. So, okay, motor cavity. I did not mean to do that. Click too fast sometimes. Okay. Cavity. That sounds more accurate. Okay, so we have everything in there. And RCA, this was, I believe, that's the one. RCA face. It's the same thing we created up there, but it's hidden within the RCA itself. Okay, back to work. So, motor's on, housing's on, RCA's on. Let's look at it as a whole. This is where we are at. And why is that sketch showing? There we go. All right. So today, let's stick on a couple of other components for giggles. First one to go on would be the cam. And let's stick that in here. Let's drag it up here for fun. And just get it out in front of the motor. We'll use the alignment tool for everything else. I want to break the link. Just a habit. And modify, align. I'm going to grab the center of this circle here, and I want that mounted to the center of this circle here. Now, during the installation process, to be honest, that will actually be a few thousandths forward. Not necessary to do right now, but guess what? Let's do this, build it, create it the way we would build it. So let's grab this cam, we're going to move it, and we're going to go to the right angle here. We're going to drag this way off just for giggles. We know we're moving in the negative direction, negative 0.003. Okay, so that's just 3 thousandths forward. There we go. You really can't even see that unless I zoom way in. It looks like it's actually still like overlapping. Nope. Oh, that doesn't look right. All right, so that's moved a 0.5 millimeter. Just for giggles, let's inspect these two surfaces. This surface to this surface is 5.03 millimeters. Because I moved it 0.03 millimeters, not 0.03 inches. You know what? We're just going to leave it. We'll leave it flush. Absolutely flush. Okay, so I just can't remember. I think this is part of the shaft and moves with it, so I can head to that. I was momentary lapse of reasoning thinking that the shaft was going to turn independent of that, but that is not the case. Okay, so we have our cam on there. Next thing we need to do is a bearing. Let's insert this bearing into the current design. Let's drag it out in front of the motor, up top. Okay, it's hidden for some reason. And we are going to break the link. Capture the position, doesn't make a difference because we're going to move it. And that has a construction plane visible from a prior project. So we'll hide that. Okay, so now I've got this. I can drag it around, but I'm going to use my trusty align tool. And oh, you know what I want to do? I didn't do in the beginning. I absolutely should have done. Let's get out of that. We're going to go. The main component here is our motor. And one thing I want to do, I almost always do right away, is ground that item. So that item can't accidentally be moved. Now, if anything else gets moved, it's going to be shifted off of concentricity with the motor. It'll be fairly obvious, but if you accidentally slide the whole thing off of origin, you start to build the next part off of origin, chaos ensues, and you have to go all the way back and find where you were wrong. So, okay, so we're going to go back into all. All right, so now we want our align tool. Modify align. We are going to grab this very, very, very center of the back face of this bearing, and I'm going to align it with the, because I know how I built these, I'm going to align it with the center of this chamfer. And then when I look in here from the right side, yeah, I should have clearance between my bearing and my camshaft counterweight, and I should have clearance between my bearing and my motor. So, and I believe, like I said, this is a 4mm cam that I had just put together for fun little projects, because I don't usually like to build anything more than 4mm stroke. I know there's some people that like that, but tattoo in 30 years, and I haven't found any real practical everyday uses for much more than 4.2 if you want to stretch it, but anything bigger just seems, it gets to be a pissing contest with some of these guys sometimes, I think. So, all right, so we got our cam on, we got our bearing on. Next one is going to be the push bar mount, so let's insert that. Really simple design again, nothing earth-shattering. Apparently I have some construction plane in there too. Let's turn it off and let's break that link. Capture position where it's at. And I think he can figure out what we're going to do here. And we're going to go back to our trusty align tool. We are going to align that center with that center. And again, check everything. No, I didn't want it that way. Let's see. Why does that? I might have built a little extra into that. Okay, let's see. I didn't build all this stuff today, so it's I'm relying heavily on my memory, which I don't. I usually slow down, check details. I usually have a big notebook next to me where I'm scratching off numbers for particular features and stuff. So, all right, let's measure the distance between that, and we have 0.2 millimeters. So in order to make my OCD section of my brain happy, we're going to grab this push bar and we are going to move it this direction, -0.1 millimeter. Now we should be centered. All right. No, we're still not there. Let's Control Z back. What was that measurement again? This talking and working together are counterproductive. Okay, so inspect that plane to this plane is 0.2 millimeters. Okay, so if I grab pusher bar mount and I decide to move it in this direction, -0.1, I should be centered, but it's not. And I'm going to go back and I'm going to look at this again, in this face to this face. No, that's 0.1. Okay, I'm where I want to be. What am I seeing that's throwing me off? I didn't line that up properly to begin with, I don't think. All right, I'm going to drive myself nuts here, so let's do it with the front face. Modify, align. This is my front surface. There's my absolute front center plane. This is my bearing. That's my front surface. That's my front center plane. That's what we wanted to see. So the bearing is now sitting centered in the pushrod mount. Okay, starting to look like something. And why not? Let's throw the pushrod in, see what we get. Okay, what's the orientation? Hey, it's even looking the right way. Okay, so let's go just okay on that because it's kind of facing where we want it. And we're going to use our trusty, nope, we're going to break our link. All right. Forgot to hit capture position. All right. So, trusty align tool one more time. I'm going to go with the center of the top of that pusher bar. I didn't model the threads on there, but this is going to be a threaded fit. And it is going to be it's Mickey. There we go. All right, so we've now got that pusher bar seated up in the mount there. May have a little clearance issue here. Not a big deal. We could create a clearance on this if we needed to. We could remove a whole bunch of the bottom of this. It wouldn't make a big difference. I know because I built it before that this bar will clear the motor. This housing may be another issue entirely. The other option would be just to extend the straight portion of this bar down a little bit, whatever we needed. Again, this was for another project, so just trying to reuse things I've already created. Even though I know if this gets to a final version, it'll be recreated specific to this unit. But I just want to know what my boundaries are, what my constraints are. All right, so that is essentially that. Now, this is where I look at this and I'm like, in the back of my brain, just always thinking, I wish I could bend this RCA to face forward. Because when I put a cover on the front of here, I mean, not only is it not going to look just like an awful lot of machines in the market, it still has that tail weight. There's very little method to get away with that. The other option is to put the cover on here as close as I want and needlessly extend this rear out so that it appears to be more centered and balanced, but not necessarily so. Or if I do that, that's a lot of unnecessary material and weight. But I'd also need to get this pusher bar back to, let's say I extend this down here. And I probably would want the pusher bar somewhere in this alignment here. So I'll be putting more of an angle on the bar or extending the angle over farther, which adds more material to the bottom of the housing to conceal this long angled bend. There's a ton of things that need to be considered. And I'm not going to get down that road right now because I simply want to demonstrate how I would build something simple and functional. So let's get back to that aspect of it. Okay, so we basically at this point have what we need. What I will do is let's do it on the face of this bar. Let's get onto the push rod. Be working on that product itself. And why is that showing as transparent? All right, so we're going to work on the face of the push bar, push rod mount. And what I'm going to do here is turn on my original origin. That's the whole machine's origin here. The outside diameter of this push bar mount is itself 13 millimeters. Okay, so what I want to do is generate, in this sketch, I want to generate a 13 millimeter circle, and I want that 13 millimeter circle distance to be from my center point. I would like that to be I'm going to call this my 4 millimeter stroke. Okay, and I'm going to create a circular pattern of this product, or this circle, and we're going to do it around the center point of the shaft, and we're going to go with 8. Sure, why not? No, that's way too much. Let's go with 4 or 6. All I'm trying to do, let's go with 4, because 4 is going to give me my extreme left and right. All right. And let's take this one and let's just make them all X, which is just, it's a construction line. Okay, so this is the northmost position of this circle, the west and eastmost position of this circle. Okay, so then what's your thought on this, Mark? Where were you going? Okay. Let's do this. Let's back up. Control Z is your friend. All right. I'm going to change this to 4.2 because we'll go to the extreme. That's about the most I would ever do for a stroke. And actually, no, that would be half of that. So realistically, it'd be 2.1 off-centered. See, this talking part makes the brain a little goofy. Okay, so then let's turn that to construction line, and let's do the diameter of this bar is about 1.5 millimeters. So let's do another one to the center of that circle, 1.5, and we're going to turn that to a construction line. Now we're going to do our circular pattern. We're going to grab this construction line, we're going to center it around this. We're going to go to 4. I'm going to finish that sketch. I'm going to turn off the motor because that's really creating some, why is this still showing? I don't know why that sketch is still showing, because that sketch is in the motor housing or in the motor itself. No sketches are on. No sketches are on. All right. Either way, the main reason for me to visualize this is that when the cam is off far right here, this is going to be the center of the cam. So I could draw a visual line from this circle down to, well, in theory, I would have to, let's do it. I'll just show you what I mean. Draw a line from tip of this ball to this feature here, and then another line from that side to the tip of this ball. Because when I design my cams, I usually design them in the lowermost position, so that I know the maximum clearance I need. Okay, so now these two blue lines symbolize the amount of side-to-side motion that the needle bar is going to get. It's going to come down one side, it's going to come up the other. So I know to some extent how much room I need there. If I want to get real fancy with it, I can grab this line and I can go 0.75 to either side. Boom. Now I know that's the farthest out extreme that this needle bar is going to move or rock from side to side. That will help me significantly in the rest of the design feature, because I need to make sure I have that clearance. Now, if the needle bar pusher, or whatever you want to call it, is longer, which it would need to be on this style machine, a little bit anyways, that pulls the bottom point down farther. Doesn't necessarily, it kind of pushes things out just a little bit, but just micro fractions, nothing extreme. So that's just a handy sketch I will create, and most likely just turn it off, because ugh, I must have created that sketch somewhere else. I did. I created that sketch up in the main, didn't I? Oh, where is it? I'm in the push rod. All right, let's just turn that off. It's hard to do this kind of in a demonstrative purpose. Usually I'm sitting there with a beer or a glass of scotch on the side. It's 2 a.m. and I'm just, fiddling to my heart's content. So to try and bring you all into this world is a little weird, to say the least. But I think it's fun and informative for the nerdier artists out there like myself. So let's get back to building a machine. So I'm getting a lag here, and I think it might have something to do with the recording aspect. So I could be wrong. All right, so bare bones, simplest design possible would be to take some quick measurements as to what's this surface here now, and the cam surface, what's that distance? That is 7.2 millimeters, so we need at least 7.2 millimeters of clearance in there. So let's do back to motor housing. Or no. We're going to create a new item. new component, excuse me, and we'll call it motor cover. Sure, that sounds fantastic. All right, now we're going to create a sketch on this surface face of the motor cavity, and we are going to, guess what? We're going to project this outside circle, and I'm going to get in real tight on this because I want to make sure I get the right line, and this one here. The quickest, easiest way to do that actually might have been to just grab that surface, and that'll give me both of those. So, okay, finish sketch. No numbers entered. I'm working with what I've already done. I've already done the work. I've already done the math. Let's use that. So we're going to extend this surface. We know we need to go 7.2. Okay, so let's think about 7.5. That's not a lot of clearance between that cam and that front casing, to be honest with you. So there's it's 0.3. That's only like 12 thousandths of an inch. So I don't think that's, now it is clearance, and I said it before, clearance is clearance, but man, let's just go a little farther on that. So let's give ourselves a full half a millimeter. So we'll go to 7.8 or 7.7. So that's 20 thousandths clearance. Now that's might be excessive, but it's plenty. So 7.7 millimeters out front there, and simply next one we want to do. Let's see if we need to build a sketch here or not. Yeah, let's do that. Let's build another sketch on this surface. We're going to project both of those. Okay, finish sketch. We are going to extend both that inner surface, the outer surface, 1 millimeter. Bam. I might thicken that up because we'll engrave a logo on the front or something, have some fun. So you want to leave a little more meat there, maybe, depending on how deeply I want to emboss that. But what we'll do quickly is go to inspect. What's the distance from our rear face to our front face? 21.7 millimeters. Okay, so that's a 7/8 of an inch. That's pretty darn tiny. Could I squeeze a little more off it, shorten that back housing? Yes, and shorten the front cover? Yes, I could easily squeeze another millimeter out of there, 1.5 if I wanted to push some issues. But why? I mean, all I would be doing is creating more potential problems for myself and the customer down the road. So not worth the effort. But I've always say 21.7. So I'm going to add the 0.3 to that last extrusion. How's that? Okay, so let's close some of this stuff. It's getting in the way. And there we go. So 1.3. That brings us up to, should be 22 millimeters from front to rear now. Exactly 22 millimeters. So that's about 7/8 of an inch. That's pretty good. Not to mention, by thickening this cover, it allows me to, like I said, do a good deep embossed engraved logo, something like that. I have some freedom now to fillet this with a decent fillet. I don't think I can go 3 millimeters. Let's see what happens. Bam! That looks okay. But what does the cross-section analysis look like? It might get thin. So, all right. You can see here, that gets a little sketchy thin, but not terrible. I would say can probably measure from that inside radius to that, and 0.6825 millimeters, so 0.7 millimeters, 28 thousandths of an inch. So yeah, that's pretty good. I'm not concerned about that. That's about as thin as I would want to push that there, and I definitely don't want to engrave near that area. but I have almost a full 1.5 mm here deep to engrave if I wanted to. I normally don't get into doing fillets and stuff like that until I have most of the main geometry constructed, because if not, working with previously done fillets, it can get complicated and the files can get huge. So, all right, so let's look at this from the side and turn off our analysis. Hey, this is the tattoo machine we've developed so far. Does it look familiar? Does it look like something else out there on the market? Does it look like a lot of things out there on the market? Well, now you know why, man. Everybody's not trying to steal from each other. It's we're all trying to do the same thing, give you the smallest, lightest, most efficient equipment out there. So nobody invented it. Nobody created it. It's just the normal engineering process. All right, so let's turn off our origin because it's going to bother me a little bit. That's the motor origin. All right. So now looking from the profile here, hey, this does already kind of come down in the body. I'm going to back off that fillet because I'm just going to turn that off. I'm going to back step one. I'll get a better visual there. Okay, so we know it's 22 millimeters from front to rear, not counting the RCA extension. Let's measure from this to this. And the distance is 9.62 millimeters. 9.625 millimeters from that direction, and let's see. Nope. What did I grab? I want the face to this. 12.375. That seems extreme. And 9.625. So, if anything, I think we're doing all right. I was going to say, it kind of visually looks centered. That's let's go to the sphere. See what that gives us. Back face to the sphere. No. I mean that. All right, pusher bar. Let's get into pusher bar. Where are you? Sometimes you got to get creative and create extra things just to satisfy your curiosity as to why something visually doesn't make sense. So pusher bar, there we go. We're working within the pusher bar now, and we are going to create a tangent plane to the face of the sphere. Now to, where's this sketch? Ah, that's why I was in pusher bar bar. All right, now we're cooking. Okay, so which sketch is this? Path, profile, sketch. Body. Path. Let's look at the path. I know that one worked. Okay. Hold on. Okay, so that'll give me this point here. I don't need to create anything. I already have it. So inspect. I want to go from the back surface to that point, 9.625. And I want to go from this surface to this point, and that's 12.375. I'm going to be honest with you, it looks more centered than that, but math does not lie. Science does not lie. So, whereas I was convinced something looked a raw, it was not. To me, this visually looks relatively centered, but it is about 1.5 millimeters off center to the back. No, actually, about 3 millimeters off center to the back, which is fine because we have this extra protrusion hanging off the rear. So let's do a quick. Let's use the tools we have here. Center of mass selection. We want to select the motor, and we want to select the motor housing, and the RCA, the cam, the bearing, the push bar. I'm not going to consider the push bar itself, just the push bar mount and the front cover. Gotta close these. It's just absolutely chaotic. All right. Okay, and then the motor cover. Okay, so we get all of that. And where does the center of mass fall on this puppy? Gotta turn it on. All right, and so this tells me from front to rear where the center of mass is on this this unit. And to be honest with you, we're not that far off, really. That's going to show me right here, and now this is going to go off of my origin plane for my entire project. So we are looking in the y-axis, so it's y 3.9, so it's 4 millimeters behind the face of the motor is where the center of mass is, which is kind of makes sense because that motor itself is 7 millimeters deep. So in theory, 3.5. So just about 4 with all the extra stuff, the RCA hanging off the back or whatever. So if I want this to be a very balanced machine, I am essentially going to make sure that my tube clamp and everything centers roughly 4 millimeters behind that plane of the face of the motor that we originally first created, where we started the whole project. That's where everything is being measured off of. So that is cool. And then I will need to create a different push bar with different bends that reaches over to that point and goes straight down the center. That means the machine will be balanced from front to rear. But once you attach a cord to it, I obviously cannot compensate for that. But an unloaded or machine that's not plugged in with just the machine, a tube, and a cartridge would be pretty damn balanced right down the center of that tube. And that's ultimately what we're shooting for. If you notice, I'll swing the center of mass around this way. Because I do build things symmetrically, you can see the center of mass is directly above, straight line up that center Z plane. Just all things I'm constantly looking at back and forth and back and forth. So did not get a whole lot done here, but I think you have a little better understanding as to what I do, why I do it, and yeah, so we made a simple cup that goes around the front here today. Took way too long to demonstrate and show, but again, you understand a little bit more about what I do, how I do it, and what my thought processes are. So in the next one, we will do the tube mounting down the front or down the center, below the center of mass to keep the machine balanced as possible. And we will create a new push bar to go into this. And once we have started on the downward mounting of the tube, when the tube chuck, then at that point we can start to stylize the housing itself and how it's going to attach from point A to point B and things like that. So yeah, I hope you enjoyed this, and thanks for watching, and I'll see you on the next one. And if you guys are just finding this series for the first time, be sure to check out the previous episodes while you're waiting for the next one. Thanks for watching.